Welcome back to this channel. My name is Akekere Benjamin and I make content on academics and basically academic pursuit. So what I do on this channel is that I will look into things that are difficult for you to understand and I'll bring it to your doorstep so you can understand better, and also we can understand and communicate better. So if you're new to this channel, please do well to subscribe to this channel, hit the like button and also turn off the notification bell. So whenever I drop a new video, you'll be the first person to be notified. Let's get down to our today's lecture. Now, what we have here today is what? Carbohydrate. I'm going to give you those simple steps and those simple strategies you need to understand the metabolism of what? Carbohydrates. Now, we have carbohydrate here. If you split this word into two, we have two words. We have the carbon and we have what? Hydrate. So what is carbohydrate? Definitely, carbohydrate are what? They are the hydrates of carbon. Very simple. The hydrate of carbon is what? Carbohydrate. In other words, carbohydrate is also a polyhydroxide aldehyde or ketone molecules. Polyhydroxide aldehyde or what? Ketone molecules. That's what? Carbohydrate. But in simple things, carbohydrate can be what? The hydrate of what? Carbon. That's just carbohydrate. That's very simple. Now let's move down. And like I said, we are not going to talk much on the chemistry of carbohydrate. What we are looking into is what? The metabolism of what? Carbohydrate, basically. So now, but before we go into the metabolism of carbohydrate, we are going to talk a little on what? The chemistry of what? Carbohydrate. Now, as we ask carbohydrate can be classified. Not just carbohydrate, because we have some building blocks of carbohydrate. So how carbohydrate can be classified? Carbohydrate can be classified based on the numbers of sugar they contain. Remember, in Greek word, what they use to assume or what they use to recognize carbohydrate is sugar. So if you hear the word sugar or sucrose, it's talking about carbohydrate. So in classification of carbohydrates, how are they classified? Is based on the numbers of sugar they have. Now, so based on the numbers of sugar they have, should I say there is a carbohydrate that have just one sugar. There's also carbohydrate that have two sugars. There's also carbohydrate that have three sugars, and there's also carbohydrates, or rather should I say 3 to 10 sugars, and also there's also carbohydrate that have from 10 above. Now those carbohydrates that just have one sugar, they are known as what? Monosaccharide. So in Greek word, saccharide means sugar. So if you hear the word saccharide, it means what? Sugar. So the carbohydrate that just have one sugar is what? Monosaccharide. And those carbohydrates that have two sugars is what? Disaccharide. So we know them as what? Disaccharide. Now, sorry for me to have to read it like this. Okay, sorry for me to do this. And this is monosaccharide, and this is also what? Disaccharide. Now, those carbohydrates that have more than two sugars in them, meaning, should I say they have 2 towards 10 sugars, they are known as oligosaccharide. And those carbohydrates that have 10 sugars above, they are called polysaccharide. But we are not going to discuss this because this is basically on the chemistry of what? Carbohydrate. What you are looking into is what? Metabolism of what? Carbohydrate. So we are going to be looking at the metabolism of what? Carbohydrate. Now let's have known the basic classification and examples of those carbohydrates we are diving into digestion and what? Absorption of carbohydrates, because carbohydrates here need to be metabolized. So before they undergo metabolism, it's not carbohydrates that will undergo the metabolism process. Rather, the reducing equivalent or the reducing block, should I say the building block rather, of carbohydrate is what is going to be what? Metabolized. Now before they will undergo metabolism, they are going to be broken down into some smaller molecules. Now that process by which carbohydrate or larger molecule of substance is broken down into some smaller complex is called what? Digestion. And let's begin the what digestion really is. And digestion, like I said, is the broken down of larger molecule into some smaller ones. So that's digestion. Very simple. When you bring a larger molecule and you broke them down into some simpler ones, it's basically what? Digestion. And where does digestion occurs? It occurs in the mouth. It also occurs in the stomach. It also occurs in the intestine. Now in the intestine, I will still divide it further. The intestine, we have three parts of the intestine. The first, which is duodenum, the second, which is duodenum, and the third, which is what? Ileum. Now this is the part, but majorly digestion occurs here. While these parts carry out absorption, you need to understand the concept. Now this part, which is the duodenum, carry out the digestion process, the last part of the digestion process, while the duodenum and the ileum, you undergo what? The absorption process, especially the duodenum. And let's come to the mouth. Let me shift this right up to this other side. Now we have the mouth. Now, these are the basic things you need to understand. There are some steps you need to understand when food is being digested in the mouth. So understand this step. Now the first step, which is what? Example, if you are taking in carbohydrate. Carbohydrate is not only starch, neither glycogen. We have so many carbohydrates, monosaccharide like I mentioned, disaccharides, oligosaccharide, and polysaccharide. Starch and glycogen, they are polysaccharide. Now if you take in starch is a complex molecule. That food needs to be broken down. So remember, the mouth contains some organs. Example, we have the tongue, we have the salivary gland, and we also have the tooth. Now the tooth, or the teeth rather, they will undergo shortening process. Now the shortening process, we break down those complex molecules into some simpler ones. After which, the saliva will enable the mixing of the food to be taken into the stomach. Now, but during the process, the saliva is produced by a gland called salivary gland. And the salivary gland produces the saliva. And in the process of metabolism is not complete. Just take note that metabolism is not complete without the help of enzymes. So enzymes must be present in order to carry out or to perform this function, metabolism. So now the salivary gland, they contain enzyme known as the alpha salivary amylase. Now, what this enzyme does is that it's going to act upon starch. Let me say, for instance, I'm talking about starch. So it will act upon this starch and break down starch into some simpler molecule. And let me just say, this salivary amylase acting upon this starch, let me write it here, and it will break down starch into some smaller molecule. So what are these molecules? Don't think that there's glucose, neither fructose, galactose, or mannose. Those molecules are these: to break down starch into maltose. Of course, maltose is a disaccharide, and also to break down into isomaltose. And take note that isomaltose is also a disaccharide, and to also break down starch into what is known as alpha limit dextrin. So now you might be wondering, or you have heard this word, alpha limit dextrin. So what is alpha limit dextrin? Now let's come back to, or let's go to glycogen. We know starch as a polysaccharide. There's also a polysaccharide called glycogen. Now glycogen is a complex molecule that is highly branched. It contains branched chain and also contains a straight chain. So this is straight chain, and we have some branched chain. But during the process, and sorry for me to even mention that, but during the process by which glycogen is broken down, there's a time in our body system by which energy is being needed, or when your blood glucose level is very low, glycogen will be broken down to produce glucose. So during the process, this branch chain will be broken down. They will be cut by enzymes. Now those enzymes that will cut this branch chain, they will not cut the branch chain completely. So now the branch chain will be very high in structure. And the process, we have a very high structure of branch chain in terms of glycogen. Popularly known as what? Alpha limit dextrin. Maltose is a disaccharide. Alpha limit dextrin is like a branch chain that is very high in glycogen. So believe you understand the concepts. So now let's move on. Remember that alpha salivary amylase breaks down starch into maltose. maltose, isomaltose, and alpha limit dextrin. But there is something that is also energizing this. Now, this process by which alpha salivary amylase, this particular enzyme here, is kind of very dangerous. So the only way to reduce that activity is when the stomach, now let's come to the stomach. Now we have the stomach. In some texts, you will see where they will write or they will explain that major digestion does not take place in the stomach. Why? It's because of the stomach contains enzymes. It also contains an acid, which is in HCl. Now the HCl, what it does is that it will deactivate this enzyme. This is the enzyme. The HCl will definitely deactivate alpha salivary amylase in the saliva. So that's why in the stomach does not play any major role in terms of digestion, but carry out temporary storage of what? Food substances. Now those food substances, they are not basically called a food substance, they are called the semi-molecule, which is popularly known as what? They are called the shell that enters the body. Should I say shell that enters the body? Now before those shell will leave the stomach, they will be converted to what? Shine. But that's not our topic for today. And the stomach does not play any major role in what? Digestion. So let's come down to what? To the small intestine. Remember the product of what? Starch being broken down by salivary amylase. Now the next thing you are discussing, which is what? We have digestion in where? The smaller intestine. Now in the small intestine, I made mention of the segment of the small intestine, which are what? We have the duodenum, we have the jejunum, and we have the ileum. At the duodenum, there's an organ called the pancreas organ. What that pancreas organ does, it secretes an enzymes, okay? An hormone, pancreatic hormone that have this enzyme. Remember, the pancreas secretes an hormone called pancreatic what? Hormone. This pancreatic hormone, and this pancreatic hormone have an enzyme. What's the name of that enzyme? It's called alpha pancreatic amylase. As you can see, the word amylase is kind of similar with alpha salivary amylase. So it does the same job with what alpha salivary amylase does. But the only difference between the alpha salivary amylase, although it converts starch into the same, which is maltose, we have isomaltose, and we also have alpha limit dextrin, meaning those food substances that are not broken down in the mouth, they will go down into the duodenum, and definitely pancreatic gland will secrete hormone that contains what? This enzyme, alpha pancreatic amylase, and it does the same job to what alpha salivary amylase will do to the system, meaning by breaking down starch into what? This product. So it's the same function. They have the same function. Okay. Now the next site in the smaller intestine we have is a basic site, which is the what? The jejunum. Now in the jejunum, there is an enzyme that is popularly called or known as what? Brush powders enzyme. Now this enzyme are very, very vital because you know why? They convert those products that is being broken down by what? Alpha salivary amylase and alpha pancreatic amylase. Those products that was converted, you will finally convert them into their various building blocks. Now what are those building blocks? Those building blocks are basically, we have the glucose, we have the galactose, and we have fructose. Fructose is also a building block. Now what it does is that, remember, we have maltose, we have isomaltose, and we have alpha limit dextrin. And these Brush borders, example of Brush borders enzymes. Now we have what? We have the lactase, it's a Brush border enzyme. Now we have the sucrase, it's a Brush border enzyme. We have the maltase, it's a Brush border enzyme. And we also have the isomaltase, a Brush border enzyme. Although we might have some other Brush border enzyme, but for the sake of this video, These are the blood-border enzymes that I have listed, but you can make a research and know what other blood-border enzymes are all about. So now the lactase, what it does is, remember, we have some products being broken down already. So the lactase, we have lactose as a disaccharide. So where is the lactose coming from? Remember, lactose is coming from milk. But the milk does not need to undergo churning process, so it will bypass the process by which the alpha salivary amylase will digest it. So it will definitely come down to the stomach, from the stomach to the smaller intestine. Now on the smaller intestine, lactose, which is lactase, will act on it. Remember, lactose is a milk, okay? So those products or dietary products that contains milk is what? Lactose. And lactose is a disaccharide. So this lactose will be acted upon by what? By an enzyme called lactase, and it will definitely break this lactose into a monosaccharide, which are what? We have the glucose and we also have the galactose. So these are the products we have. They are also called the simple blocks, but they're called the building blocks of what? Starch. Now we also of carbohydrate. We also have sucrose. Now sucrose is gotten from table sugar or simple sugar rather. Now simple sugar that goes into the system are not broken down exactly from the word alpha salivary amylase. They're broken down by an enzyme called what? Sucrase. Now sucrase will definitely act on it and break them down into what? Into glucose and what? Glucose. So sucrase will act on it and break down sucrose into fructose and what? Glucose. The same thing with what? Maltase. Now we also have maltose. So remember, those maltose that are broken down by alpha salivary amylase, they'll be broken down into what? Maltose to give glucose and glucose. Now the last thing we have is isomaltose. Isomaltose will still work on what? Isomaltase will work on isomaltose, okay, to give maltose. Then again, maltase will now work on what? Those maltose that is formed from what? Isomaltose to give twins of glucose. And the last thing we are going to be looking at is alpha limase dextrine. Now remember that alpha limase dextrine is also a product that was broken down by the alpha pancreatic amylase and salivary alpha what? Amylase, or alpha salivary what? Amylase. So how is alpha limase dextrine broken down? Now this is alpha limase dextrine. What will act upon this complex molecule, or should I say a molecule that was broken down by the alpha salivary gland or salivary amylase, is this? We have the isomaltose. Now isomaltase we break down this into what? Maltose. Remember, maltose is not a building block, okay? Maltose is never a building block. So what will happen is this: maltose in return will now be broken down into 2 units of what? Glucose. By what index? What's the enzyme that can be able to be broken? That can be able to break down maltose into 2 units of what? Glucose. Which is what? Maltase. Now maltase will now break down what? This into 2 units of what? Glucose. So in summary, what are those basic molecules or the building blocks that we mentioned? As can be able to recall, we have mentioned so many building blocks. And building block number 1, we mentioned glucose. We also mentioned galactose and what? Glucose. These are one of the basic building blocks that need to be absorbed in the system. Now, this is all about digestion. So before absorption will fall, we're supposed to know what transport system is all about. Transport of glucose, or you call them glucose transporters. In the cell of the small intestine, there are some cell membrane that contains transporters. So in this video, we are only looking into what digestion of what? Metabolism. In our next video, we are going to be talking about the transport system, or should I say the glucose transporters that carries this molecule into the bloodstream, and from the bloodstream they will go into different pathway. Please click the like button, subscribe to the channel so that whenever I drop a new video, you'll be the first person to be notified. Thank you.